Here in this video, we are solving a NEET 2016 problem from the concept from the chapter Optics. The problem says an air bubble in a glass slab with a refractive index of 1.5 near normal incidence is 5 cm deep when viewed from one surface and 3 cm deep when viewed from the other surface. What is the thickness of that slab is? So if you try to draw what he is saying, there is a glass slab, so this is a glass slab. In the glass slab somewhere there is an air bubble. This air bubble is at some distance from one surface x, from the other surface at another distance y originally. But when viewed from outside, you are here. So person is in rarer medium, object like air bubble is in denser medium. So whenever object is in denser medium and you are observing from a rarer medium, it appears nearer to the surface. That's like a coin or a lemon in a water glass. If you drop it and if you see, it appears as if like it is not at the bottom, rather it is at a height from the bottom. It is not actually at height from the bottom, rather it is appearing like that. That's called apparent height. That we have already derived in the previous videos. You can see how it happens in terms of light rays, but we can say it appears nearer. So what we can say is here, refractive index mu of the material of the glass with respect to surroundings is, real depth is more. Real refractive index is always greater than 1. So higher value real depth comes to the top divided by apparent depth. So what we can say is that mu, which is given like 1.5, is real depth in the first case is x, whereas in the second case it is equal to y, but it appears as 5 cm deep and 3 cm deep. So its apparent is 5 in one case and 3 in the other case. In all that cases they are equal. So what we can find out is the value of that x is 1.5 into 5, that is 7.5 centimeter. The real depth from the other surface y is this one, is 1.5 into 3, that is 4.5 centimeters. So the total thickness of the slab is, glass slab is x plus y. That's the total thickness. So how much is that x plus y means? X is 7.5, y is 4.5. 7 plus 4 is 11 and 0.5 and 0.5 is 12. So the depth is, the real thickness of that glass slab is 12 centimeters. That's how we solve this problem. Let's have a look at the second problem. What the second problem tells you is, a small coin is resting on the bottom of a beaker filled with liquid. A ray of light from the coin travels up to the surface and moves along the surface. So when it moves along the surface, that we have to identify, right? See, if this is a particular angle of incidence, for a particular angle of incidence, the light ray grazes the boundary that is separating the two media, and the angle of refraction is 90 degree. That particular angle of incidence is called critical angle. So here the angle of incidence is critical angle. It is given that this is 3, this is 4, obviously this is equal to 5. So what happens at critical angle is, so we know that at the critical angle mu equal to 1 by sin c. So what is this sin c in the triangle is, if this is c, this is also c. For sin c, this becomes the opposite side and this becomes the hypothesis. So mu equal to 1 by sin c means 3 by 5. That is equal to 5 by 3. Once if you know the value of the mu as 5 by 3, we can further write mu refractive index as velocity of the light in vacuum by velocity of the light in that medium. Mu value for any medium is always greater than 1. So if you have any confusion whether you have to write C by V or V by C, you can simply understand C in vacuum is always the highest, 3 into 10 power 8 meter per second. Velocity of the light in any medium is less than that vacuum. So as mu is greater than 1, it always comes as C by V, never V by C. Be careful about it. We know that mu equal to 5 by 3 equal to 3 into 10 power 8 by V. That implies V equal to 9 by 5 into 10 power 8 meter per second. So 5 ones is 5 and then 4 is remaining 40, that means 5 8s are 40. So 1.8 into 10 power 8 meter per second is the answer for that problem. So it's a simple problem. You can solve both these problems this way. Thank you for watching.